Chapter 9, Inheritance and Interfaces, Part 1. In this chapter, we're going to learn about inheritance. We are going to implement subclasses that inherit and override superclass methods. We are going to understand the concept of polymorphism. We're going to understand the common superclass object, which I like to call the super-duper class, and work with its methods. And we're going to work with interfaces. So, to think about inheritance, in object-oriented programming, inheritance is a relationship between a superclass, which is more general, such as in this example, vehicle, and a subclass, which is more specialized, in this example, car. Note the UML diagram on the right-hand side of this slide that indicates that car is derived from vehicle. Car extends vehicle. We also use the terminology car is a vehicle. The is a relationship is the inheritance relationship. So the subclass inherits all the data and the behavior, the variables and the methods from the superclass. Here's another example of a hierarchy. We can have at the top the most general, in this case vehicle, and then some more specialized, motorcycle, car, truck, and then even more specific. So we can have different types of cars, a sedan, an SUV. Just a little fun aside from my days with the car industry, which were brief. However, the SUV is not a car, it is in fact a truck. And that was one of the ways that they were able to be so successful, is they built it on a truck chassis, and it was not subject to the same regulations as cars back in the beginning. I don't know what it's like now, but just a fun little fact. The substitution principle means that we can use the term is a to test to make sure that it is that the inheritance relationship is sound. Car is a vehicle. Car shares common traits with vehicle, plus car has some more specifics. It doesn't go the other way around. Vehicle is a car does not fit, because there are more things that are a vehicle besides just a car. You could have a golf cart, you could have a tricycle, you could have a motorcycle, etc. So we can say car, my car, equals new car. The keyword new, it's an operator, and it does three things. It allocates sufficient memory for the object, it calls the constructor, and it returns the address of where that object is in memory. So anywhere that we can use an object of type, where we use an object of type vehicle, we can substitute an object of type car, because car is a vehicle. And here again, I apologize for bringing this up a little bit late, but car is a vehicle, and that's how we demonstrate it in the UML diagram. I frequently find it helpful when I'm looking at code that I haven't seen before to draw those little UML diagrams, to just sketch them so that I can keep track of where things are. So let's examine a quiz example. Assume that we want to create a quiz that will have different types of questions. Fill in the blank question, single answer, multiple choice, numeric answer, free response. They're all three different types of questions, and a question can have some common characteristics, such as it can display its text and it can check for a correct answer. So here's an example showing the superclass for question. It handles only strings, and it has no support for approximate values or multiple answer choices. So it's got a text for the text of the question, and then the string for the answer, so it can check the answer. Note the constructor at line 12. That's the default constructor because it's not taking any parameters. And then at line 22, we have a set text method. What type of method is that? Is that an accessor or is that a mutator? If you said mutator, you are exactly right, because it is changing one of the instance fields. Also, I just want to call your attention to the Java doc comments that are used starting at line 18 for the set text method. We've got a brief description of the method and then at param that identifies what the parameter is and what it's used for. If we had multiple parameters, we would have multiple at param comments in our method comments. Those are the same type of question, method commenting style that they use on the AP exam. Continuing on with the question class, we've got a set answer method that sets the modifies or mutates the answer instance field. We've got check answer that checks whether or not the user entered a correct response. Notice that it says response.equals answer, so we are checking what the user passed in against the instance field answer. And remember that equals returns a true or a false. The equals method returns a true or false at line 43. So that method check answer returns a Boolean. It either is correct or it is not. And finally at line 49, public void display, we have a display method that just displays the question. So here's an implementation using test class question demo 1, and we have a main method inside that class that creates a new question object at line 13, question Q equals new question. And then we're setting the question text, who is the inventor of Java, and the answer, James Gosling. Then we display that question and we prompt the user to input their answer, and then we check whether or not they entered the correct response. If you have some time, I encourage you to type this up and get it running, or download the files from the Student Companion online. Let's take a look at a self-check. Consider classes manager and employee. Which should be the superclass and which should be the subclass? Remember the is a test. Manager is a employee. That seems to make sense to me, rather than employee is a manager. So manager is a employee. That means that employee is the superclass and manager is the subclass. Self-check number 2. Oopsies, sorry I screwed up the animation on that one, but that doesn't matter. What are the inheritance relationships between bank account, checking account, and savings account? Checking account is a bank account. Savings account is a bank account. So both checking and savings are subclasses of the superclass bank account. Consider this UML diagram of the exception classes. This is a partial, it's not showing all of the all of the exceptions, but assume you have a class runtime exception. What's the superclass for runtime exception? If you said exception, you are correct. So list all the superclasses of runtime exception. Given this example, we're missing the throwable class in this example, but given this UML diagram, the superclass for runtime exception is exception. Exception's superclass is throwable.